Okay, so this is just one more tool and one more hint, and basically you know what to do. This is a continuation of what we did in the last one. So here's a hint. I want you to keep in mind that e is just a number. So if you're looking at like e to the minus x, you should probably think about 2 to the minus x, which is equal to 1 over 2 to the x. So that's my little hint. It's also equal to 1 over 2 to the x. So that was my little hint about e. Don't be scared off by e. It's just a number. Okay, so there's something that we're going to talk about, which is called the limit comparison test. Okay, consider that we have two series, one that we're very familiar with and one we know zip about. We don't know anything. So what the limit comparison test gives us is if you take the limit as n goes to infinity and you compare these terms, an over bn, or bn over an, it doesn't really matter, and it's equal to some constant, okay? Now, I'm usually thinking about all these as being positive, but you can take the absolute value if you need to. This is intended for positive things. Anyway, they both have the same fate. If these guys limit to a constant, then both original series that we wrote have the same classification or the same fate. I'll say classification. So if one converges, they both converge, and if one diverges, they both diverge. And so let's talk about it this way. This guy, we know it converges, and we can do a comparison versus 1 over n squared, for example. We can use the integral test to tell you that 1 over n squared is a convergent, or we can use the integral test directly on 1 over n to the fourth, all that good stuff. Now, because when we move from here to here, from the first series to the second series, we're increasing the denominator each time, so that means we're clearly making this guy smaller, right? So it's really easy to compare term by term, and that's why those questions were posed first to you, to try to build some intuition. Now what we're doing is we're leapfrogging past that and saying, okay, it's really silly to restrict ourselves to like +3 or like increasing this denominator. If you decrease this denominator by a smidge, it really isn't going to matter. And you could have actually used the comparison test and index shifting to do that, but it's just easier to say, look, we have another tool called the limit comparison test that lets us leapfrog directly from 1 over n to the fourth to 1 over n to the fourth minus 3 without worrying about index shifting. We just go ahead and run this test with the limit. You divide an over bn, and you take the limit as n goes to infinity, and we show that in this case it equals to 1, and there you're done. So that's what it's useful for. So I have a note to myself for number 4, so maybe it's probably a quiz question, and if not, I'm going to go ahead and pose this to you on the screen here. So this is a takeoff on something on the worksheet. And it says a is greater than 0, but I'm adjusting it. I'm saying if a is greater than 1, find, we just know this much, find smallest value of a so this guy diverges. And this is a bit of a review. I'm going to encourage that you use this kind of approach to this. Think in terms of an integral test. You're going to want to do, okay, you want to do this sort of thing. Okay, so the reason why I'm sort of pointing this out, I want you to realize just really in a concrete way that natural log of a is just a number. And so you could abstract this away by saying, forget it's even natural log of a, just call this thing b. What value of b are we looking for? And then backtrack to figure out what a must be if you're looking for this to work out, okay? Or you could just rewrite this integral this way so that you understand, hey, x is the thing I'm looking at. So again, it's very similar to asking this question. Work that out, see what B's you're okay with, and that'll tell you what A's you're okay with. Okay, and I think that's all the hints for now. This should get you through the worksheet, and I'll see you in class.